Alrighty. Just a few more pages left. Step 1, absolute value by itself. Absolutely. There are no operations happening outside our absolute value. So we have negative 5v minus 6 less than 44 less than looks terrible. Great. Or okay, so we're going to use and here, and negative 5v minus 6 greater than negative 44. Okay, when you're creating those two inequalities, inequality flips and you make it negative. Okay. It's a little hard to write sometimes on this. That's better. All right, so we're undoing subtraction first. (5v less than 50). Undoing multiplication is always going to be the final step you do. Multiplication or division. And for undo subtraction with addition, negative 5v greater than negative 38. 5 by negative 5. And v both inequalities were going to end up going in the same direction. Oh, I couldn't see my negative sign. There's my issue. So this is negative. We divided by a negative. Inequality changes direction because we divided by a negative. Then we have less than 38 over 5. That's a little bit more than 7. So I'm going to go less than here, greater than, oh, it's negative 10 now too. Okay, so 50 divided by negative 5 gives us negative 10, in addition to the inequality changing direction. So greater than negative 10, less than 38 over 5. Oh, that one was fun. Everybody makes mistakes. For 28, absolute value has to be by itself. We're going to undo that division with multiplication. Gives us absolute value of k less than 35. It's less than, so it's going to be an and. K is less than 35. K is flip the inequality and make it negative. All the PowerPoints are still online if you want to check back on any of the rules here. We want to be greater than negative 35 and less than positive 35. And inequalities going towards each other. Good news. All right, our last two inequalities are absolute value questions. All right, so I noticed that both of these have negatives. First of all, they're inequalities, and so you could have no solution, but it's beyond the scope of what we're talking about with these guys. But if they're equal signs, you might say, oh, no solution, they're negative. Well, you have to get absolute value by itself first. Over here, we're adding 6 on both sides. So that gives us the absolute value of r over 10 less than or equal to 1. Over here, we're dividing by -3. Okay, I cannot stress enough, there is no operation between the 3 and the absolute value bar. It can't be addition, it can't be subtraction. Addition and subtraction go between the two things that are being added or subtracted. Couldn't be addition or subtraction. So we do have the option of multiplication here. So we divide by -3 on both sides. So that gives us absolute value of -p plus 2 greater than or equal to 3. And now we have a positive there too. So I just wanted to kind of look at that for now. We'll come back to that in a second. R over 10 less than or equal to 1. R over 10 greater than or equal to -1. Flip the inequality and make it negative. Undo addition. No. Undo division with multiplication. R is less than or equal to 10. Undo division with multiplication. R is greater than or equal to -10. It's a less than, so it's an and. So we're going to be less than or equal to 10. Greater than or equal to -10. And connect them. All right. So when we divided by a negative, the inequality changed direction on number 30. And -9 became +3 when we divided it by -3. So we're going to set up our two inequalities. -p plus 2. Oh, I remember what I wanted to say. This inequality here, this one right here, that's the one we're using to decide and or. So this is an or, because it's great or, and it's an or because we cannot decide and or until absolute values by itself. Okay? In this step, absolute value is not by itself yet. So you can't decide. If it was an equation, you couldn't decide, no solution. Since it's an inequality, you can't decide and or until absolute value is by itself. So we're greater than or equal to 3, less than or equal to -3. Subtract 2, subtract 2. -p greater than or equal to 1, -p less than or equal to -1, divide by -1, divide by -1. Okay, we want to solve for positive p, not negative p. Can't have your p being negative. So p is less than or equal to -1 or, okay, we're deciding here that it was or, and we're dividing by -1, so we have p greater than or equal to +1. Looking back at my graph, we're greater than or equal to +1, less than or equal to -1. And that's an or graph. Alrighty. Just quickly. Okay, less than, greater than, dotted lines or dashed lines. Solid lines for less than or equal to, greater than or equal to. We're shading above for greater than and greater than or equal to, below for less than or equal to. The only time we're using right or left is if we have a vertical line. So that would be like x less than 2, x greater than 3, or less than or equal to, greater than or equal to, etc. All right. Okay, x lines are vertical lines. It's at -1. Oh, it's a solid line because we've got the equal to bar. And it points in the direction that you're going to shade. So we're going to shade over here. All right, cool. Y lines are horizontal lines. Okay, so it's a dashed line this time because it's not an equal to. And we're shading below, so that's going to be hard to do. Just down here. I mean, technically it's all of this space too, to infinity and beyond. Okay, shade below for less than. That's the end of page 4. I think we'll do pages 5 and 6 in one video, perhaps.